Welcome everyone to the ActivityBot 360 Educator Workshop Day 1. For any of you who would like to follow along with the slideshow, and I recommend that all of you keep a copy of this slideshow. So I'm going to paste that into the chat. Eventually I will. All right, there you go. So there's a link. If you're watching on YouTube, there'll be a link in the description. You can also just simply type in this short bit.ly link, or if you're wanting to have it on a second device, like a mobile device, you could use this QR code here. With you today is me, Andy Lindsay, Ari Alvarez, our company vice president, and Stephanie Lindsay, our product and documentation manager. Thanks to Ari and Stephanie for your assistance behind the scenes, and also for jumping in if you see important questions in the chat. My name is Andy, and my background is mainly in electronics engineering, but I've ended up wearing a lot of hats at Parallax, including textbook authoring, development of educational kits, work with circuits, program designs, web apps, just lots of different stuff. And of course, teaching professional development workshops. Most recently, I've been working a lot with the CyberBot robot and a electronics educational kit. And if you're interested in seeing those workshops, I embedded links to all of them. So for example, if you wanted to see the YouTube that's equivalent to this for the CyberBot robot, you could follow the 3 sessions link. And then up top, you will see links to the 3 videos, and each one of those will take you to YouTube. And then down at the bottom, you'll see the workshop presentation slides. And this you will also have access to. We'll send out a link to this near the end of the workshop for this workshop, because this will become one of the previous workshops, and you'll have the description, the video links, and the slideshow link all in one spot. And then we have a similar thing for the electronics training kit. So what are we going to do during this workshop? We'll start with intros and overview, which we're in the midst of. We'll also review the homework that was done by you all and me prior to the start of this workshop. And there are links to all that. So anybody following along, even later on YouTube, will be able to follow the homework instructions so that they can be ready and then get started with the hands-on activities in this workshop. We're going to then test our electrical connections that we made in the homework to make sure they're right. We'll build a speaker circuit and play some tones. Then we will calibrate the ActivityBot 360. And actually, pardon me, I believe that, oh, no, it's okay. We need the speaker for calibrating the ActivityBot to get some audio feedback on how it went. Then we'll do some basic maneuvers. For homework, we'll be doing, we'll all do a Blockly how-to and some circuit basics, and I'll talk about that right at the end of the session. On Wednesday will primarily be this navigation with sensors. So we'll get to use ultrasound and then whisker contact sensors. Friday, and for homework, we'll build and test the infrared and get ready to access teacher resources. Then on Friday, we'll do some infrared troubleshooting, some infrared navigation, look at the project and applications available for the ActivityBot, as well as educator resources. We'll talk about the upcoming workshops, which is actually singular right now. There is one coming up after this, and then we'll be scheduling some more. How to purchase, and questions and answers, and wrap up. And that'll be it for the 6 hours of workshop. This is my first time doing this workshop, so this is my guess at what we can fit in, but I'm going to slow down as needed. And so we might end up, omitting one of these activities. We'll just, see how it goes, and then I'll know for next time. Parallax is just outside of Sacramento, California. We have roughly 20 employees and have been around since 1988 and serving education since 1997. This is Chip Gracie. He started Parallax and is our chief inventor, and his brother Ken is the company CEO. And together they've really left a great mark on the electronics and educational community. As far as what Parallax is about, the main idea is that we create and sell electronics prototyping and educational materials. And this is modern electronics where you have some kind of programmable device that's connected to circuits. So for example, in this alarm clock or in this microwave, behind the buttons and the display, there's going to be circuits that are sensing the button presses and a microcontroller that's processing them and then updating the display, making a beep to let you know you press the buttons and stuff like that. So those are, it's basically stuff that's found inside products, but we also make it available for prototyping so that people can make interesting inventions in student projects. This all got started with the basic stamp in the mid-90s. The basic stamp was the first of its kind in that it took putting a programmable device into electronics and made it approachable by everybody by using the basic language and by having it be something that you could just plug into a computer and go, which at the time was a very unique thing. And it pretty much changed everything. After that, Parallax got a lot of requests for educational curriculum around it. And so we got started with that too. And the Bobot robot shown here with its basic stamp microcontroller was our first example of a rolling robot that's used for education. And it incorporates circuits. And then there's an electric mechanical aspect with the wheels and lots of good curriculum behind it. It became very popular. And so every time a new popular microcontroller was released and made available, we built something around that very similar to what students did with the Bobot robot. And so if you're interested, for example, in these lessons with the Arduino, they exist. With the BBC microbit, they exist. And then, of course, this is the ActivityBot robot that you'll be working with during this 6-hour session. Okay. So here is an advertisement. Okay. So this is the ActivityBot robot here, and Parallax designed and makes this tiny little square right in the center. This is called the Propeller microcontroller. And like the basic stamp for its time, it is also a very unique and revolutionary microcontroller. And the ActivityBot 360 is also a little bit unique from its other robot siblings in that instead of 3 wires, black, red, and white, which is ground, power, and control signal, there's a 4th yellow wire. And that allows this servo to tell the propeller at what position it has turned, or to what position it has turned. So there's a constant angular feedback that the propeller can use to help improve navigation accuracy. So for those of you who have taken the taken the class with one of the other robots, you might remember that we had to use a screwdriver to manually adjust the robot. And then we also had to adjust the programs to make the robot go straight ahead. And with this, the whole system basically takes care of that for you, and you can use simpler statements to tell the robot where to go. So something about this Propeller microcontroller that I mentioned earlier is that most microcontrollers have one processing core and some memory, and then they have some external pins that for power supply, as well as to control and monitor circuits of various types. And what happens is, when you're developing an application with this kind of single core microcontroller, behind the scenes, what the microcontroller has to do is spend a very brief period of time on the group of things you're making it do very rapidly, one after another, only spending a tiny amount of time on each. With the Propeller microcontroller and its 8 cores, your program so if this is a robotic application program, the main core might be this portion of the program, or rather this portion of the program might be executed by the very first core to start the robot. And what it might be doing is just checking the circuits and then telling some of the other cores what to do. For example, one of the cores might be monitoring the angular position of the servos and then adjusting the signal to make sure that it stays exactly where it needs to, either while it's moving or staying still. And so that this core will set the memory. This core will go and get that memory and then update the servo position and or speed accordingly. Meanwhile, you could have some music playing, or some kind of custom audio playing that might be stored on an SD card, which is read by 2 cores. And then it might play music, and that music output would be by a, let's see, 1, 2, 3, 4, by a 5th core. And we've still got 3 left over. So that's an example of how robotic applications with the ActivityBot differs from applications with the other robots. In practice, though, when you're writing the code, it doesn't look a lot different, because it all gets abstracted. And so one robot might have a statement setting the servo speed, and it'll just keep going on that speed for a while. Whereas we'll have a statement setting the servo speed, but instead of multitasking, only maintaining that servo speed, only spending a brief amount of time maintaining that servo speed before returning to some kind of main loop, it will instead just focus on setting those servo speeds. Incidentally, with 8 cores, sometimes a single core will actually be multitasking. So you've got 8 multiprocessors, and then some of those might be doing more than one task at the same time as well. That might sound really extra high tech and difficult, but with both the Blockly Prop and C languages, it's very simple, very much like lessons for the other robots as well. There are 2 flavors of tutorials for the ActivityBot robot. The first is the Blockly Prop language. And so this is a graphical programming language, which we'll see more of, but I'll just show you very quickly. You're going to see blocks that look like this. So the blocks connect together, and this is how you build a program to be executed by the Propeller. There is also a set of C language tutorials, and there was an optional step in the homework for setting up the simple IDE software. And so this uses basic C language. So here's an example of just a C language tutorial getting started with C, and it's a text-based language that is even after 30 years, or oh gosh, no, it's more than 30 years. It started in the late 80s, and so this is another popular way to get involved in programming a robot, and also you can do lessons learning multi-core as well. And I will show you what I did was I added links that correspond. So we'll be looking at links in the ActivityBot tutorials, but down in the speaker notes, which you can just lift up by grabbing 3 faint dots at the very bottom of the slideshow, if there's a corresponding link to a C language tutorial, it will be down here below the, and I'll show you when we get to a slide where there might be a corresponding tutorial. Real quick up front, just wanted to let you know that we have student resources. So these are the 2 tutorials, and each one of them, if you click the photo, you will see a link to those. And these are all at learn.parallax.com. Oh, I'm sorry. Actually, that's coming later. Maybe not. Okay. So these are the student resources. They're all at learn.parallax.com. And you can click either of these tiles to go to the book cover of either the Blockly or the C language tutorials. We also have teacher resources for everything that we have educational material for. And you can get to the main area by going to learn.parallax.com/educators. And specifically for the ActivityBot, it's learn.parallax.com/educators/resource/ActivityBot resources. And then when you go there, and we'll talk about this more on Friday, when you go there, it will show a number of teacher resources that, because of the fact that they're not questions and answers, they're here up front. So for example, if you wanted to do a standards alignment, here is the standard matrix. And again, we'll take a closer look at all this on Friday, but just wanted to let you know it's here. And then also there's a login link. And when you have signed up with Parallax or learn.parallax.com, we check to verify you're a teacher, and then set you up with an account, and you can log in here. And that's when you can get to the assessment materials that have both questions, exercises, projects, and solutions. I also put a link for purchasing robots up front. I'll also mention this again on day 3, but basically if you go to www.parallax.com as opposed to learn.parallax.com, then it's /product-category/ActivityBot-360, and that will take you to all things ActivityBot 360 on our e-commerce site. Any questions or comments before I move on to the homework review? Okay, well, I'd like to mention that you're always free to unmute yourself and say, hey, Andy, I have a question. Also, if you chat something, oh, I stand corrected. Thank you, Chad. It was the 70s. I don't know why I was thinking the late 80s. That must have been one of the important iterations of C language. Yeah, because I'm remembering something like 88, and Chad will probably chat me, let me know which that was. Okay, and all right, so anyway, yeah, feel free to chat, and Stephanie and or Ari might jump in and let me know, or you can just unmute yourself, whatever you're most comfortable with. Okay, so the first thing in the homework, so all the homework is listed here in a summary form. And the first thing we did in the homework was install the Blockly Prop launcher software. This is a little piece of software that is a conduit between a Chrome browser and the communication chip on your ActivityBot robot. And so, well, we first did the cover page of getting started with Blockly Prop Solo. And the reason we went there is just to make sure that you have, for example, a Mac or a Chromebook or a Windows machine with a USB 2 port and stuff like that. After going to the cover page, the first activity is installing the Blockly Prop launcher. And it basically sends you to, first it sends you to a downloads page. And then you can download for your operating system the Blockly Prop launcher, and Chrome sends you to the web store. So once you're done with that, and your Blockly Prop is all nice and installed, then we had to connect to your Propeller activity board here, and then actually write a Blockly program. And it showed you how to click the menu along the left, and then, or the categories along the block categories along the left, and then select a block that did a particular job, in this case, saying hello to the terminal. And then using the load and run once, or load RAM and run, we saw hello in the terminal. And then there was an optional activity of adding an extra line of text that again would appear in the terminal. After that, there was just a quick thing about saving projects, which is really easy and straightforward in Blockly, because in the upper right, and I'll show you this in just a little bit as we're doing hands-on Blockly programming, there's a save and an open button just in the upper right. And somewhere there, I skipped the part where you give it a new name. See where it says hello right here? You can click that and change the name and then hit save, and then you've renamed your program. And when you save or open, it saves to your downloads, and then as an SVG file, which is a kind of graphic file, and then open will take you to your downloads to open it. You can also move those files around and then simply save to a different location and open from a different location. Or rather, when you save, it'll go to your downloads. You can move it somewhere else. And when you open, you can browse to that somewhere else. After that, we built our robot. Oh, and this is where I'm supposed to mention, by the way, that, oh, apparently it's not. I thought that this was where yes, okay. It just took it a second to appear. This is where I set up the C language equivalent of, installing the Blockly Prop launcher and going to solo.parallax.com, writing a program, loading it into the computer. That is all set up simple IDE. So this is a software that's that you can run on Windows or Mac, some flavors of Linux and Raspberry Pi. And one important thing here is that this last link where it says update your Learn folder, you'll need to do that because that contains the libraries for the Propeller to talk with the ActivityBot 360. And so this is a crucial step. I get calls from time to time, why doesn't my ActivityBot work? And one of the first things we ask is, did you update the libraries? And a certain percentage of the time, the answer is no. And then everything's fixed. But it'll save you concern and head scratching to just remember, if you're planning on using the C language version, that that there is a library update that you have to do before working with the ActivityBot. In the homework, also, we oopsie. Yeah, so here again is the C language equivalent. I thought I might have put it on the wrong slide. Okay, so for building the robot, there are several steps. For the first is to check your hardware. Next up is step-by-step putting the O-rings on the wheel. And at every step, what we do is we show you the parts, and then we sometimes show the process as an animated GIF file like this, and then the final result. In other cases, like prepare the chassis, we show you the parts to gather. Oh, yeah, we still have, and then we show you with an animation how to put all those parts on, and then what it looks like when we're done. And in that way, we try to support both you and your students as much as possible putting the robot together. And that brings us to the last, I believe, homework item, which was the electrical connections. These are the most common place where students get stuck because they don't necessarily follow the instructions very carefully. And so my recommendation on this part, after building, we do the electrical connections, connect the servo motors to the board. And what we have the students do is, first of all, they have to set this little tab here. They have to remove it from the lower 2 pins and then slide it down over the upper 2 pins. And so then the top view is like that when they're done. And then we have them also make sure that their cables are labeled with the left and right servo. And here is the left servo and here is the right servo. So here at the top of the page, we have, information on which one's the left servo, which one's the right servo. And so then down at the bottom of the page, they will have already labeled their servos, and they just need to make sure to plug the left servo into the correct port, the right servo into the correct port, and likewise for the yellow feedback wires for the left and right servo. And there are things that are built into the calibration process that can catch problems here and report them. And I'll show you that in a little bit, because inevitably a certain number of students will make a mistake here. And until they fix that mistake, the calibration won't happen. There is some default calibration that they can still use, but especially if they have a pair of wires swapped, their robot would behave somewhat erratically until they get this connected correctly. Anyway, this is a really important step. So I'm going to show you, we're going to go through that as the first hands-on activity. Well, the second and third hands-on activity, actually. Because we had all of you do the electrical connections. So you have this is where we stop the homework. Is that right, everyone? Okay, good deal. So that means we can start doing some hands-on stuff. And the first thing I would like to do is make a beep. And there's a reason for that, because as I mentioned earlier, there's some audio feedback that the Propeller can give us during calibration. So chat. Select everyone, paste. Okay, so this is the page that we are going to do. And one thing I recommend when doing these activities, both to students and to you when you're learning it, I'm going to switch this over to another desktop. What I recommend doing is having the tutorial. If you have enough screen real estate, you may need to have them overlap some and switch back and forth. But ideally, if you have enough monitor real estate, have your tutorial on one side and then the Blockly prop editor on the other side. So I'll I'll paste in the Blockly prop 2. And then in the upper right of your Zoom, you there will be a little button where you can adjust your view so that Zoom is not filling up your whole screen. That way you can move Zoom aside, continue watching what I'm doing, and then potentially move stuff around in the solo.parallax.com web app. So there is solo.parallax.com. I'd like you to open that up. And I'd like everybody to either, if you, like I said, if you have screen real estate, like if you have 2 screens, you can put the tutorial on one side and you can actually have the tutorial overlap with something like imagine that this is your Zoom window. It's my second camera, but for you, it might be your Zoom window. And so you could actually have your Zoom window here, and then you might find yourself switching between your Zoom window and the tutorial. And to do that, in Windows, it's Alt-Tab. Actually, in Mac, I think it's Control-Tab. And I think in Chromebook, it's also Alt-Tab that allows you to move between applications. So if I hit Alt-Tab, or pardon me, I'm in a Mac, so Control-Tab. If I do that several times, it'll show me a list of all my applications that are open. And once Visualizer, or in your case, Zoom, is highlighted, you can switch back over to it. So Alt-Tab or Control-Tab to switch between applications on the left. Does everybody have it so that they can see the Zoom presentation and the Blockly prop editor? Okay, I got 1 thumbs up. Thank you, Marcel. Stephanie, would you be able to unmute yourself and describe what that Zoom button looks like? I can't get to it as a presenter.
Oh, for changing the view?
Yeah.
It should be, at least from my perspective, it's in the upper right corner, and it is a little square with a rectangle on bottom and 3 dots on top. And if you click it, you can choose full screen or standard side-by-side speaker, side-by-side gallery. You have several options right there. You can, once you've also exited full screen, you can resize your window if you like.
Thank you very much. Okay, so that would be setting up your screen so that you can get to Zoom and a tutorial page and your Blockly prop solo, the solo.parallax.com website. And next up, this introduces, or this is one of the, this is a little bit out of order because I'm going to have you go back and do some circuit and programming lessons between today and Wednesday, or at least that's the plan. This is assuming you've already been through a couple of pages that explain how to build circuits. So what I will do is I'll try to show you close up how to do that. So here we are. Oh, that's something I forgot to mention in the homework. There was also getting some paper plastic bowls, 5 new batteries. Here's the built-up ActivityBot. You will need your serial cable. You'll want to connect that to your ActivityBot. If you haven't already done so, like me, do it now. All right. And for this, we'll go ahead and have you okay, so your ActivityBot will probably look about like that. And I need to make this not upside down.
Your text is currently upside down on the PCB.
Yeah, I'm trying to fix that.
You could just turn the robot around.
Well, I could. The difficulty with that is
There,
that
now it's correct.
yes. The reason I try to do it in software is because that way I don't have to work on the robot upside down on my end. All right, so here we are. And then in your robot box, there's going to be a small bag with the label that says 572-28132, and it's going to have some small parts on that. What I would recommend is to grab one of your plastic bowls or trays, and then empty out that bag into the bowl/tray. And then this speaker right here is actually going to be in a small bag with 2 red light emitting diodes, a couple of push buttons, and a couple of 3-pin headers. So look for the bag that has the little red LED bead looking things. And in there, you'll actually have also the piezo speaker. So go ahead and tear open that bag and grab the piezo speaker. And then you will also need 2 wires. And one of the things that I do out of laziness is I basically pull aside a wire, and then I push it through I cause it to punch a hole in the bag. And so it's like a little jumper wire dispenser. And so what you can do is grab a black and a green and a blue, pardon me, wire. So these parts right here. Okay, how are we doing? Everybody got those parts? Give me some thumbs up or thumbs down. Thank you, Stan. Thank you, Ari. Thank you, Marcel. Thank you, Sheila.
We have a request to give Marianne a second.
Okay. You got it. Thank you, Jason.
Okay, we've got a set from Sylvie.
Excellent. Yeah, sorry, I missed that. I was looking at
How are we doing,
something else.
Marianne? Happy smile from Joseph.
Awesome. So once you've got those parts,
All set.
excellent.
Okay.
Once you've got those parts, we're going to build it like this, but I'd like to show you basically the pin underneath the plus has to go in the same row as this blue wire here. And then the other pin has to go in the same row as that black wire. Then the black wire will jump to a black ground socket and the blue wire will jump to a black socket labeled P4. So first thing I like to do is put in the speaker. And so that's gonna look like this. Okay, so see if I can get a good angle here. All right. So the speaker is going, actually, it might be nice to put the blue wire in the fourth row from the bottom on all the way to the leftmost white socket. So we'll put the blue wire in the fourth row from the bottom and the black wire in the second row from the bottom. Then we'll take our piezo speaker and we want the plus to be kind of rotated slightly upward. And then when you tip the piezo speaker, it's got two pins and those two pins need to go into and you'll need to rotate it a little bit. So if you have it straight up and down, it won't naturally go into the row. So I put the bottom pin in the furthest socket from the black wire. And then I rotate it over and put the upper pin so that there's one empty socket between the blue wire and the pin. And then press it down. So that's the long story. The short story is just basically that you want to have each pin of the piezo speaker sharing a pin, sharing the same row of 5 sockets as a jumper wire has.
We've got it done from Sylvie. Any thumbs ups?
Nice work, Sylvie.
What's everybody else doing? There's one. Sheila and Stacy got thumbs up. Matt. Oh, 5 thumbs up. All at once.
Excellent.
I think we're doing pretty good.
Now that we didn't have anybody who did 2 thumbs, right?
I don't think it's an option.
Okay. Well, if you're not video muted, you can do it. All right. So then next up is to take the black wire and plug it into ground, GND, any of the sockets labeled GND down here, black sockets labeled GND. And then along the side, you want to be the 5th socket up. So, or rather the 4th if you're starting from 0. So this is 0, 1, 2, 3, and 4. So P4 and GND, and then the other ends of each of those wires has to go to the same row of 5 as a pin that the piezo speaker is in. Once that's done, and again, your students will be working from this diagram here, which also we have a wiring diagram, but we also always include a schematic. Now, after your students have built this up, then they're going to be running then they're going to make and run some test code. And this frequency has two places where it can be. If you note the color, you'll note that it might be, see how that matches the color of pin states, but it also matches the color of audio. And under audio, we have frequency out, and then that's where the frequency pin duration frequency block is going to be. So again, click audio, select frequency out, and then click frequency, and you'll see pin duration and frequency is the top one, and it'll place it. Now, if you accidentally place two, like I just did, you can drag one of them down into the trash can in the lower right. And so that is the equivalent. Again, I'm doing this a little bit of out of order since we're working in a 6-hour format as opposed to in the classroom. And so you would have done this somewhat earlier, and also done stuff leading up to it to know where to find the blocks as well as how the circuits work. And again, you'll be doing that stuff between Monday and Wednesday. Which is why, and so it does say from the audio menu, select the frequency out block. So that's audio, frequency out, and then select the matching block. Okay, last but definitely not least is we need to set those values so that they match what we see in the example here. So that's going to be pin 4. So you can click the 0 and then select 4 from the drop down. Now duration is not a drop down, it's actually called a value block. And so you'll have to click it and then 0 will be shaded and you can enter 1000 in its place. And then click the frequency block and enter 3000. All right, how's that?
Studious quietness.
Yes, indeed. One thumb. One thumbs up. Thank you. 2 thumbs up, 3 thumbs up.
Oh, a good point. David mentioned for his ears, he has to use a frequency of less than 3000. So that is a really good point that you can go for a higher pitch or lower pitch that suits you.
That is an excellent point. So 3000 is a pretty high pitch. And so, yeah, you could certainly do 2000 or 1000.
Now, what's the good range for these piezos? Because I know that it varies a little bit from.
Yeah, so the screaming range, because they're the kind you might find in a smoke detector, I believe, is 4500. So that's when you're going to get the loudest you can get.
Your students will experiment and.
Yeah. So it gets a little bit softer as you go further from that 4500 in either direction. So like once you're up at 6,000 or 7,000, the speaker just can't vibrate enough. It, you know, compared to that frequency, it's like a woofer, even though it really is a tweeter. And then on the lower end, yeah, it's going to get quieter and quieter as you reduce your frequency, and down at about 400. I think it starts to get really choppy at around that, but we'll leave it at 3000 for now.
We're getting some thumbs up, and we do have one person checking the circuit because they did not get a beep.
Oh, okay. So you guys are ahead of me then, because you've got your Blockly prop launcher running. which I do not yet.
Was that part of the homework though to,
It's
Uh,
true, that was part
yeah.
of the homework. And so for me, that's Finder, applications. I might have it on my desktop. Let's see. Well, I'm just gonna, since I'm presenting, I'll just do this quickly from here.
oh, we do have one report of the high-pitched beep waking up a puppy.
Please send our apologies to the puppy. We did not intend to interrupt its slumber. So once you run the Blockly prop launcher, looks like this, and it should tell you if you have your propeller board connected over USB, it should give you a connected. And after it does that on your solo.parallax.com, it should give you serial port options. I have two, and with the Mac, it normally looks like this kind of thing. With the Windows, it's just going to say COM and then a number like 5 or 3 or 10 or something like that. Okay, so I'm going to put mine right by the, so you need to, one last step on my end is that we need to set the power from 0 to 1. And as soon as I did that, oh my, as soon as I did that, a different program I had in the robot started running. So now that that's done, what we can do, and when you load a program, you'll see some serial activity near the serial port here, so that there'll be P31 and P30 light that will twinkle as the program loads. So I'm going to load it, and I don't know if the camera will catch that or not. Well, it appeared to twinkle very briefly on my end, that the program loads quickly. And then now every time you press and release this reset button, the RST button right here, it should beep. So I'm going to put this closer to the mic, and now I just heard a beep. Can you guys hear that? Testing 1, 2, 3, beep, 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 beep. Okay, excellent. I was told that noise canceling on my mic only causes some of the tones to be audible when I'm speaking. All right, so now that we've got that done, I'm debating whether to take a break or move into calibration. So navigation basics is the next thing that's up. And
Perhaps we could do the break now in case anybody is having trouble getting things working.
That's a really good idea, Stephanie.
Just to make sure that they've got the piezo working and knowing that they've got their editor up and can download code.
Perfect. Okay, so in that case, let's take a 7-minute break. That means we'll come back at 5 past the hour, because it's just coming up on 2 minutes before the hour. So we'll have you all return at 4:05 Pacific, 5:05 Mountain, 6:05 Central, or 7:05 Eastern, depending on where you are. See you then, and we'll hang out for troubleshooting as well as questions and answers.
And we will be recording during this break. Okay, Andy?
Yes.
Can you take a look at the chat? Compile succeeded, download failed. Chad's having trouble getting the code to download.
Okay.
I don't see it in the chat.
Oh, it's chatted just to me. Okay. The message is compile succeeded, download fail, loader message, scanning port com5, cannot set port com5's options, DTR equals false.
That's very interesting. I had one other teacher report that to me. And Jeff Martin, our software engineer, said that typically closing and reopening Blockly prop will make that go away. Although I would also suggest, if that doesn't work, to unplug and replug the USB port.
Or even reboot. That's what my problem was, Andy. I remember I rebooted.
Okay.
And that did work. Excuse me. I did have an issue with the same thing as we were working, but I did unplug it, shut it off, put it back on the robot. I did all these things and it popped back up finally. I exited out Blockly. So it goes in and out, it feels like.
Yeah.
Periodically.
So one thing about that is Chrome just updated to 106.
And we just talked about that when we were emailing today. I had 106 that just popped up, and you said the same thing as we were emailing back and forth today.
Chad, I'm almost afraid to have you go look at the settings though, in case it updates your Chrome and then you have to restart the application. Although during the break, I guess would be the time to do that. Let me get the email from our software developer. There you are. Okay, what Jeff said is that message comes from launcher where the system refused to let it control DTR. Now, and he says he's seen it happen from time to time, but haven't determined exactly what causes it. And he said from memory that it can be related to the project he's running. He said it happens very rarely, and the only workaround he knows of is to close and restart the launcher. And then it says you can leave Solo open if it's running in a separate browser. So we're at solo.parallax.com. So yeah, try closing and reopening the Blockly prop launcher, and then try reloading the program and see if that fixes it. And by the way, I'd like to collect, Stephanie, can you please make a note for me to follow up with Chad and Stan in case we need to have Jeff check in with them and possibly get some diagnostic information, because this is a potential opportunity for us to find and fix a bug, be it from a Windows update or in Blockly prop itself. It's hard to determine. Sometimes a Windows update will introduce, or an operating system update more generically, can introduce things like that. Likewise, Chrome just updated to 106. So that may be why we're seeing this. So we'll need to look at that more closely. Oh, Chad, you're 106 now? Because I remember you were 100 the other day. So it sounds like Chrome updated on you, and I'm beginning to wonder if the interesting thing is we just did a Cyberbot robot course, and the Chrome 105 update caused certain things not to work for programming the microbit, and it took a couple weeks for Google to fix it. And this is their fix. And so there's always the possibility that we're seeing this. Killing the browser window did not help.
The 106 is with the Windows laptop. The 100 was with the Mac.
Okay. And then are you getting the error on the Windows laptop or the Mac?
The Windows.
Okay, that makes more sense because the discussions we had regarding Stan's report of this was that it had to be Windows. Since it was a COM port DTR thing, that's what they thought it was. Now, are you still stable on the Mac?
No, that's in another room.
Oh, okay.
Andy,
Yes.
this is Sylvie.
Yes.
My husband works at Google. He works on Chrome OS.
Uh-huh.
Depending on the problem you have, if you send me the error report with what you diagnose on your side, I can forward that to him, and from there they could see if it's something that is due to the version, or they might be able to help out or send you to the right area.
Oh, that is outstanding, Sylvie. Now, could I follow up with you on the particulars of what information they would want? Normally, for example, there's a console that we can look at inside the browser to copy messages, but there are also debugging features that might have information. I just don't know, what exactly they'll need, but we could try to capture that for them.
Totally. We finish at 5 o'clock, but today is not you won't be back on time, but Wednesday he should be back home by 5 o'clock, so you can actually talk directly to him.
Oh, excellent.
So if that helps you, but you have my email address, so please feel free to send an email. If he can't help you, say, I'm sorry, I can't help you. You have to file a report with so-and-so, but if he can help, he'll be happy to help.
Oh, that's fantastic. Well, thank you again.
You're welcome.
Chad, do you have simple IDE on that Windows machine, or can you switch to your Mac? I don't want you to be stuck unable to program.
Yeah, I can bring up the simple IDE.
Yeah. Let me know if that will, let me know if that still works. And the reason I'm asking Chad that is because we talked about a plan C where basically if you look at this program, and I know this that we did run across this in the homework, but I forgot to mention it, is that there's a code button up here. And so when you click the code button, it actually shows you the C language code that Blockly generates. So this is what gets compiled and then packaged and sent to the Propeller microcontroller, is this C language version where it says freak out, and then we've got pin 4, 1 kilohertz, or 1,000 milliseconds or 1 second, and then 3,000 hertz or 3 kilohertz for the frequency of the tone. And in the activity, we have the students try different frequencies. And then you can click blocks to go back to your block code.
We are at 4:07.
Thank you. And so incidentally, so what you can do if you have simple IDE installed, that's the C programming software, is you can simply copy this C code that was generated and paste it into simple IDE. And that was simply a backup plan that we had because we were talking about issues with his particular computer and not being able to load a program into the Propeller, that something was getting in the way. And so we came up with that as an alternate plan. All right.
It's building right now.
Okay. Yeah, on Windows, it should, well, it takes a little bit longer. The build times on the server for Blockly Prop are really fast. Okay.
I heard a beep.
Oh, perfect. Okay, so you're still running. There's just going to be an extra step for you. Excellent. So here we are now starting navigation basics. The first thing we want to do is to test those electrical connections we made. And by that, I mean that during the homework, we did some electrical connections up here. We set this little jumper tab, slid it over the upper two of the 3 pins that are sticking out next to these servo ports. And then we carefully connected the wires. And so this is the servo port or servo cable on the right, and it should be connected to the right wheel, which is the one that's closer to the power switch. And then likewise, I'm sorry. Yeah, so that the one on the right should be connected to the right wheel. And then this one on the left should be connected to the left wheel, which is closer to the servo ports. There's a program that we can run to do that. And I am getting you a link to it because I forgot to put it in the slideshow, but I will have that for everybody. Let's see here.
We can't hear you, Andy.
Okay, thank you. Can you hear me now?
Yes.
Oh, excellent. All right. Okay, so I am grabbing you a link to a test encoders script. Pardon me, Blockly program. I just accidentally pasted that directly to Chad. Okay. Get link. Paste. Uh-oh. Get link. Apologies, I am having Chrome not give me the link. It says it's working.
I'm going to give it a try. Let's see if it's this one you're talking about.
Yeah, it's testencoders.svg from the Google Drive I shared with the hosts.
Oh, no, the feedback 360 servo test. Oh, you need a specific code.
Yeah, it's a pre-written thing. It's something that
What's the name again?
It's testencoders.svg.
And how you want to share it again?
Yeah, if it would be possible to just, I mean, normally what I can do is I can simply right click testencoders.svg, and then there's a copy link option. Somebody asked if they should put the batteries in the robot. Yes, yes, the batteries should go into the robot for this also. And normally what the students do is you can see on my screen, hopefully the block program, but I wanted to save us some time since it's a largish program, especially compared to the piezo speaker one. So let's try one more time here. Get link. Oh, hey, I got Copy link. I got it.
I just pasted one in the chat.
Oh, thank you so much, Ari. Excellent.
I'm not sure on the permission, so I need people to try it.
Yeah, so what happens when you follow that link is you should be presented with a screen that looks like this, and there's a download button. And you should be able to click the download button, and then testencoders.svg will appear in the ribbon at the bottom of Chrome where the downloads show up. So can I get some thumbs on if you were able to download the SVG file? 1 thumb down, 2 thumbs up. Okay, 4 thumbs up. 5. Marcel, you're outnumbered. 6.
Getting some positives too in the chat.
Okay, excellent. All right, so now that you've got that downloaded, and I hope you can catch up with us, Marcel.
He did.
Good. Then the thing to do is, first of all, we want to save our work here. So we have this frequencies program, and I forget what the name of that was. So in the instructions, they have you save it usually. I guess since it's just one block, but let's name it beep by double clicking the name field, whatever name you had in there, type beep over it, and then hit the save button. So now you'll have beep. And then once you've got your code saved, let's go ahead and hit the open button and then select choose file. And then in your downloads, you should have testencoders.svg. And if you sort by date, one way it'll end up on the bottom, the other way, ascending versus descending. If it's descending values from larger to smaller, your most recent date stuff downloads will appear at the top. And so you can just go ahead and open it from there. And then click the open button. And then there's a second open button to confirm it for the browser. And then the pre-written version should appear in your Blockly prop. So again, click open. Click open. I'm just going to disregard that. Open. Well, since I'm having trouble repeating that because it wants me to save the program again, I'll just wait and see if I can get some thumbs up from you guys.
My screen looks just like yours, Andy.
Excellent. Ari, thank you. Stacy, thank you. Sylvie, thank you. JB, thank you. All right. Joseph, excellent. So it looks like most of us are now have it open. So what I want you to do is there are 3 green buttons up top in Solo. And I want you to hit the one that's pointing down towards a line. What that's going to do is it's going to load the program in, and in a way that in a way that allows you to rerun the program anytime you want. You can turn off power, turn it back on, and it will rerun. And when you fly over, in very small letters, it says load and run, save code to EEPROM. That's the storage for programs on the Propeller activity board. The run once load code to RAM button that's next to it, well, it's only going to run it once, because when you restart the Propeller to run something again, everything in RAM disappears. So we want to use load and run save code to EEPROM. Okay, and once it's loaded, can close the dialog. And then we want to take a close look at our ActivityBot. And this is the right wheel. Again, this is the wheel that's closer to the PWR 3-position switch. So here's our right wheel. And what I want you to do is grab the right wheel and very gently rotate it, not very quickly, just a little bit, and keep an eye on the light that's labeled P27. It's right here. It's basically near the right wheel, and kind of close to the metal post or the attachment point to the chassis in the lower right corner of the board. And so basically you're rotating the right wheel. And so we want the right P27 light to be turning on and off as you rotate it. Then, and it's best to rotate the right wheel until the light turns back off. That way you can see whether or not, when you rotate the left wheel, and again, that's the one over here by the servo jacks / plugs. So when we rotate the left wheel, we want the light labeled P26 to turn on and off. Now, if it so happens that instead P27 was turning on and off when we're expecting P26 to be turning on and off, what that means is that these two yellow cables up here are swapped. Okay, so right now mine, the one you're seeing here is correct, because the P26 light on the left of the two lights is turning on and off as I rotate the wheel that is by the servo ports. And then when I rotate the wheel that is by the PWR power switch, the P27 light turns on and off. And so that's the confirmation that you have your feedback cables connected to the right lines.
So if you're getting P26 for the left wheel,
That means, again, if you're
is
getting
that correct? Do you need to?
P26 for the left wheel is correct. P26.
Yeah. And
P20
P27 for the right wheel.
Yeah, so the
And if
right
you-
wheel, this is the right wheel. It's closer to PWR, so P27
Okay.
should flash.
And then
and
you
then-
should just swap those servos if it's not working right, if you're getting it backwards.
Well, if it's backwards, yes. So the main thing is, okay, is P26, when you rotate the right wheel, the one closer to the PWR switch, as I'm doing right now, if P27 is blinking, you know you've got them right. If P26 is blinking, you know you've got them swapped, and you need to re-swap them.
And you need to swap both the
Nope, just we'll find out more about the servo cables in a minute.
Okay.
But we want to get the feedback wires correct.
Okay.
And so now if nothing's happening, sometimes those feedback wires are supposed to be connected to the topmost of the 3 pins here. So 1, 2, and then we see the feedback wire connected over the P14 topmost pin, and then the other feedback wire over the P15 topmost pin. So these are the two servo ports there. So there's going to be a total of 4 pins visible. If you don't see 4 pins visible below the two connections, that could explain why no lights are blinking here. So that's another thing that you can check if you're not getting any blinking. The other thing that would potentially cause no blinking is that, well, my batteries are in. You need to be, or not in. I should have added those. You need to be in position 2. And I'm going to add my batteries right now. And anybody else who doesn't have their batteries in there will be needing them soon. So let's go ahead and put the batteries in. Okay, so how are we doing? Have we all verified that our yellow feedback wires are good? All right, way to go, everyone. Give me a shout out if you need some time or if it's not working for you. Okay, next up is calibration. So again, all these things that I'm walking you through in the interest of time are step-by-step tutorials. So here we have a video of what it looks like when the ActivityBot is calibrating, and the students can play that to see what to expect. And then we have step-by-step instructions that tell you to go to the robot block menu and select ActivityBot 360 calibrate. So that's what we're going to do next. But first, of course, let's say, or we don't even need to save our work because you downloaded test encoders. So you currently have that in your downloads. So it might not let me not save it. Let's see. I hit open. Okay, the current project has been modified. Click yes to discard the changes and open an existing project. So yes, we can discard the changes. Boom. And then we want to, okay, I'm sorry. I'm giving you bad instructions here. Let's try this again. We want to do a new project, not an open project. So click the new button. And the project name can be Calibrate ActivityBot. And the board type we want to make sure is the Propeller flip. No, I'm sorry. The Propeller activity board. Board type is Propeller activity board. Project name can be Calibrate ActivityBot. And then hit continue. All right, and then the instructions. The instructions say to click the robot block menu and select the ActivityBot calibrate block. So here is the robot block. Robot. And then ActivityBot 360 is a little ways down. You might need to use the scroll wheel on your mouse if you see a scrolling bar here. For me, I'm able to get to it on my screen. But if it doesn't appear, if you only see down to set speed max, for example, then you'd need to scroll through the menu to get to ActivityBot 360 calibrate. Okay, so let me know when you have that program set up. Thank you, Stan. I hope that was a thumbs up. Excellent. Thank you, Jason, Stacy, Joseph. Way to go. Oh, you guys are looking great. Okay. And again, just shout out if you need another minute. Now, once you've got ActivityBot calibrate set up, the instructions that the students are following are here in a bunch of checklist instructions. So I'm going to tell you what to do in place of that. And it's going to be important to first of all, you're going to download to EEPROM that downward arrow to the green button, but be ready to set the power switch to 0 immediately after or immediately when the two lights come on. So I'm going to go to the video footage. Okay, and we'll get my lights both off. Okay, now if you have turned your wheels so that both your lights off, what you're going to do is you're going to hit the load double EEPROM. And then as soon as these lights come on, you're going to take this 3-position switch right here and set it in the off position. So watch first and then do it yourself. So I'm going to hit the load and run, the downward arrow to the bar, boom. So it's going to compile and load. And then the yellow lights, the P26 and P27 lights are going to turn on if it ever completes its loading process. Okay. Boom, and turn it off. And by the way, it might lurch forward, and pay very close attention to forward. Before you do this, forward is going to be this direction. So forward is this way. If it goes backwards, that means these 2 3-wire servo cables are swapped and you'll need to unswap them. So again, when you set the 3-position switch back to 2, you want the robot to first lurch this direction, and then it's going to start spinning in place. Again, if it lurches backwards, or if it simply doesn't do anything, or maybe shakes, it might even play a uh-oh tone. It'll any of that means that there's an electrical problem. So
What's the program again?
the program is the one we have right here, ActivityBot 360 calibrate. So we're going to hit load and run, the download to double EEPROM, the downward arrow that points down at a line.
And you found that block where?
And we found that in Robot, ActivityBot 360 calibrate. I'm not going to click it because I'll end up with a second one.
Okay.
So again, when you load that, as soon as the lights come on, then the robot starts to move, cut the power. And let's just make sure that we're all at that step. And then I'll show you what it looks like when the calibration runs. Okay, give me some thumbs up once you're ready. Thank you, Marcel. 1, 2, thank you, Stacy. 3, thank you, Stan. Oh, wow, 4, 5, 6. Thank you, Joseph, Sylvie, Stacy. Thank you, Jason. Matt, all right, looking
We
good.
have Sheila Nielka in the chat also.
Awesome. Okay. All right. So now I'm going to show you what happens. And there are several important things to either do or not do. First is you want to disconnect the USB programming cable because the robot is going to spin in place after it lurches forward. Hopefully I can get a good enough view here. Yeah, I'll try it here and then maybe move it to the floor or maybe just pick it up and recenter it. So the first thing it's going to do is lurch forward, then it'll start turning in place. So there's the lurch forward. Now it's turning in place one way, turning in place the other way. Then it's going to turn in place with pivoting on the other wheel from which it first turned in place in both directions. Now, don't turn it off yet. And then it played a do-do-do-do-do-do because it succeeded. Don't turn off power until these little lights go back off. So the little yellow lights, amber lights, the P26 and P27, they both turn off, and that is the conclusion of the calibration. Then you can turn off power and reconnect your USB cable. You may want to put this one on the ground for this activity. If you end up with the cable swapped, I don't remember it. It either just kind of shakes a little in place, like it's shaking its head. And here, I'll just swap the cables. No, it'll either shake in place or it will start backwards. I believe that it can't start backwards if the servo cables are swapped, because we already know that the signal, that the feedback wires, the yellow ones, are correct. So if the yellow ones are correct and the servo cables are swapped, I believe it just stops and kind of shakes in place and plays the uh-oh tone. And just give me a thumbs up if you, well, if anybody did not see the robot do that dance, give me a shout out. Right on, 2 thumbs up already.
We have a report from David. Mine ran left, right, stopped, beeped. Now when I hit reset, nothing happens.
Oh, and that's the expected behavior. So thank you for commenting on that. That program actually destroys itself after it runs once. Because we don't want people accidentally recalibrating itself. So that the last thing the program does is make it impossible for it to run again unless you reload it using Blockly. Okay, I think that's the 5th thumbs up, might be the 6th. Wow, this is great. This is probably the best turnout I've seen during a session. Anybody stuck? Or are we all calibrated? Nice. 7. All right, now, if let's say that your robot did not do the dance, let's say that it just stopped. Well, first of all, if it backed up instead of going forward, that would have meant that both the cables were swapped, but because we checked the signal cables first, we might know that, well, basically that it should probably just sit in place and shake and play the uh-oh tone a couple times. So one thing you can do, and we want your students to do, is to verify, is to either find out what happened or verify that the calibration went correctly. So what I'd like to do is right-click this calibrate block and select disable block. And again, this is all part of the tutorial. So basically the calibration was the main activity. And then after talking about how it works, and by the way, the encoder, the thing that knows the angle that the servo has turned to, is actually a little bar magnet that's over a 2-axis Hall effect sensor that measures the direction of the overall direction of a magnetic field applied to it. And in try this, we do another program that is ActivityBot 360 display calibration results. So everybody, again, you want to have the right click disable block and then go to Robot and select ActivityBot 360 display calibration results. And then run that. Either of the 2 downward arrows are fine for this one. Oh, don't do like me. Remember to turn on your power before you try to run the code. Okay, so I just turned the power on and I'm going to try to rerun that code. Okay, so I got a thumbs up and a couple of messages saying that that calibration worked, you're ready to go. So for some reason mine still isn't. Let's try load EEPROM and run. There we go. So the last calibration worked, you are ready to go. That's what it's going to say if you succeeded. If you did not succeed, it's likely to say, hey, maybe your servo cables are swapped. You know, swap the 3-wire cables, try your calibration again, then come back and do this again. And some of your students may need to try that several times before they've ferreted out all their wiring errors if they weren't careful. Since we were all careful, we got it on the first try. Congrats. And excellent work, everyone. Although I may have spoken too soon. Did we all get the good message? Yeah, I was going too fast. Sorry about that. 2, 3 thumbs up. Power supply problem. Okay, so so we got one power supply problem. There's 2 possible sources of that. One is, well, there are several sources. One is if you have batteries that are too tired because they were, for example, taken out of a game controller or the back of a drawer, that can do it. Some batteries may be too hot, although I mean, these are the hottest batteries as far as like the voltage they start at that I've been able to find. So I don't, unless you have higher power batteries than me. The most common explanation for a calibration that reports that there's a power supply problem is this little tab right here that I talked about earlier. So this little tab might be a better view. This little tab right here might not be over the 3 pins. I'm going to take it off. Okay, so these are the 3 power pins, and you need to slide the tab over the upper 2, and then retry the calibration program. I almost slid it over the lower 2. That would have caused a power problem report. So those would be the things to check that tab. And then if you don't have new batteries, now it should actually work with the default calibration. So I'm going to go ahead and move ahead. And because your robot should still move, it just may not move optimally with a power problem. Okay, so to rerun the calibration, you would right-click the display calibration and disable it, and then you'd right-click the calibrate block, enable it. Now, if you've already successfully calibrated, don't do this, but you can basically go back and forth between these two. So we could load this into EEPROM, turn off the robot, put it on the floor, set the power to 2, let it run again. And then when the little lights come off, then go back, reconnect it, right-click the calibrate, disable it, right-click the display calibration, enable it, and then try again, and hopefully you'll get the right results. But don't worry about it for now. Let's just run with its defaults. And by the way, for tech support, there's a display calibration data, and that will actually show us the numbers that it put in its permanent memory. And we can potentially, talk about the data and see what was measured. So that's another thing that we have built into this block. Okay, so I'll go ahead and save that. And then we'll try running some programs. The first one is going to be just going certain distances. So this is the driving distances activity that I'm going to go to. I'll paste this in so you can see it in the chat. Paste. All right, so there's the link to the page in the chat. And the way this works is that there are 64 different positions that the wheel can turn to. And we call those ticks. Like if you imagine the old bicycles, sometimes you'd put from a deck of cards, you'd paste a card to your fork, and then each spoke would pass by that card and it would make a tick as you're riding your bike. I don't know if anybody saw or did that as a little kid, but that's the best way to think about it, is that each spoke going by would amount to 1 tick of that card. And so what you can do is know that a full turn is 64 ticks. And also it so happens that that 1 tick is 3.25 millimeters. So you can also think about how much distance each wheel will turn. And the first example, and by the way, if you want to go forward, you could go forward, for example, by 2 full turns. That would be 128 ticks for each wheel. Or you could go left, for example, -26 and +26, or right. That would be +26 for the left wheel, -26 for the right wheel. Backward would be both negative. And so this is information that students read through first, and then we have an example program to do. And we have 12 minutes left. So how about if I give you that example program? Let's keep our fingers crossed that I can actually get it out of my Google Drive this time. What was the name of the program? Let's see.
It was drive distance ticks. But you
Yes.
have 2.
Drive distance ticks. And I'm in a big race with Ari now.
I think I have it, but I'm going to wait.
He's probably going to win because I'm still trying to get back to Google Drive.
Okay, so I just put that one then.
You win.
Let's see if that one is the one.
All right, so I'll go ahead and follow the link.
Drive distance ticks.
Whoopsie. Yeah, drive distance ticks.svg. And so again, it's going to come up in your in a new tab. Just hit the download button, and then it'll show up in your downloads. And then after that, you can
You need to go to
hit the
open.
open button. Yep. Choose file. And then drive distance ticks is going to be slightly older because it's going to have the date of the time I saved it, I think. I don't know. It
Do
should
we
be
have
near the top though, if you have it sorted by date.
Should we have our activity bots off? for power?
On or off is fine right now.
Okay.
To save battery, it's usually best to turn it off when you're not using it. And you can also just simply have it in position 1. That's good enough for loading code. And the nice thing about position 1 with just the light on below the 1 is that it won't lurch and run off on you immediately after you load the script. So I would recommend everybody set their 3-position switch, the PWR switch, to position 1. And then after that, you'll want to use the load to EEPROM button. Again, that's the arrow pointing down at the line. So we'll go ahead and load that in. Because I have it in 1, nothing's going to happen. And that's by design. It's intentional. So we're just going to wait for it to load the script, the block code. And you could probably hear the speaker and so that means that the program started. Now, the ideal thing to do then is to go ahead and unplug it. Well, actually, I should mention, okay, so in the code, we have 3 blocks that are robot. There's robot, ActivityBot 360 initialize. You always need to start the program with that. Then drive distance in ticks, and we're going to go 128 forward and for both wheels. And then another drive distance in ticks, and we're going to go, we're going to turn in place by -26 ticks. So the left wheel is going to go 26 ticks backward. The right wheel will go 26 ticks forward. So it should execute a left turn. So let's try that. Now, 2 full wheel turns, I'm going to pick up my robot and kind of pull it back towards the end of the screen. So basically disconnect your USB, turn power off to 0, and then move it all the way to 2. And it's going to go forward. I'm going to keep on pulling it back. Then it turns left, and by about 90 degrees. Press and release reset. And you can see it again. So that's what it should do. And then before you plug it back in, it's usually best to set the switch to 1. That way, plugging it in won't possibly restart the program and have it run away on you. Okay, can I see some thumbs? 1, 2, 3, 4, 5, 6. Excellent work, everyone. 7. 8. Okay, so this went forward and then made a left turn. What I'd like you to do next is click, still compiling. Yeah, mine has been compiling kind of slow too. I'm going to talk with the folks that are in charge of the Blockly prop system and see if it's scaling properly. So what I'd like you to do is hit Control and select the repeat forever block and just place it off to the side. And then I would like you to change forever by clicking it to X times. I'll do this one more time. I'm doing the next step in that activity, again, from memory, as opposed to going through and reading and following the instructions. And then hit value, select the 0 block, put it in there, and change the 0 to 4. Okay, so I'll do that one more time. So we're going to click Control and select Repeat Forever. Then we're going to click Forever and change it to X times. Then go to Values, select the 0 block, put it inside that empty puzzle piece in the repeat, and then change the 0 to 4. Okay, let me know when you've all got that going. Nice. Okay, looking good. Excellent. All right, now here's the tricky part. What we're going to do is we're going to grab this, and as you hover it over the blocks, it's going to allow you to insert it somewhere. And we're going to insert it between the initialize and the first drive distance block. Or you can just grab the robot drive distance and drag it away, and then put the repeat 4 times in there. And then take your stray robot drive distance blocks that go forward and turn left and put them inside this little opening right here. See how that works? And then the opening gets larger to contain it. Thumb up. Yes. Oh, now don't be doing the sideways thing. I want some definitive yeses. All right. Oh, hey, we got more than a thumb up. We've got a party popping emoji from one of the attendees. That looked great. Didn't realize those were available. Cool. All right, so if we're ready now, basically it should repeat that pattern. Oh, I forgot to load the program. You got to load the program into the EEPROM just like before. So arrow down to line with a 3-position switch in 1. And wait till it's done compiling and loading. Then you can unplug, once you hear the beep, you can unplug the USB, set the switch to 0. Then for this one, I think it's probably best to set it down on the ground. Then set the 3-position switch back to 2. And it will go in a square. Since we executed the forward and left 4 times. Nice. 2 thumbs up. Thank you. 3 thumbs up. 4, 5. 6. 7. 8. Awesome. So this is the first of several navigation things, and we'll go ahead and just finish off the tail end. There's a couple of more navigation lessons, but we're going to save them to the beginning of the next session. And specifically, what we'll do at the start of the next session is we'll do, instead of driving a fixed distance, we'll set it at a particular speed for a particular time. The advantage of doing this is when you have sensors, you can interrupt a given speed. Whereas if you're doing a maneuver where you're telling it go a certain number of ticks, you can't really break into that. You just have to wait till it's done. So we have the ability to set speeds as well. And then we'll talk about different kinds of turns. So those will be 2 real quick things at the beginning. Now for your homework, what I want you to do is I'll send you links to, I'm not sure, I'll either send you links to these slides or just, kind of put these links in an email, or maybe both. All I want you to do is go through these blue links right here, the learn to program, variables, terminal talk, and values and math. And not the whole thing either. Just I know you guys are busy. It's during the week. You've got to teach and grade papers and all that other stuff. So for variable blocks, I only want you to go through the did you know section. So you'll go to variable blocks and you'll try it out. It'll show you, okay, click the variables, hit new variable, give it a name, and then keep on following the instructions. And you'll have a my number equals 0 and a my text equals hello, and just keep on following the instructions. And when you get to did you know, it said through did you know. So stop here. Don't worry about the try this. I want to save you some time just to get a feel for Blockly programming on your own and at your own pace between this session and the next. And same with terminal talk, but we're only going to go to the try this heading. And then likewise, that's the same with values and math. Now I have making decisions and blocks that repeat and some of these others grayed out. They're kind of optional. And the reason they're optional is because basically the other part of the homework is just trying out a few circuits. And when you try out those circuits, what'll happen is in check push buttons, you'll end up using a block that repeats and a block that decides. So as opposed to, going through and doing the terminal only version of decisions, We're just going to do it with a circuit. And you'll want to be very careful when you build these circuits to, and feel free to drop me an email if anything isn't working as you expect. But so it's going to show you a diagram of the circuit. I should do the light first. So basically, get ready to build is going to tell you about the different features of the breadboard, but it's also going to talk about how to, no, I guess it didn't. Let's see. Sorry. Yeah, so here we're introducing the light and we're introducing the resistor. And then we're doing a little breadboard diagram. And you'll actually just place your 2 red lights. You don't have a red, yellow, and green. Just place 2 of these. Oh boy, I should have, I'm going to have to update this. I'm going to change the link, but basically it's going to show you how to build the circuit, and it's going to call out certain things like you want the longer pins of the LED, that they have 2 lengths of pins. You want the longer pins on this end. You want to make sure that everything, when they're connected, it's in the same row of 5, and you'll need to double check your circuit before going and building the script to make the light blink. And so that's an example of just doing some things with circuits. And you'll need to, again, make sure that when you're connecting 2 wires together, that you get them in the same row of 5, just like we did with the speaker circuit. And you'll need to use your magnifier probably to check the colored stripes on these, which are called a resistor, which were introduced earlier in this page. And I may end up changing this link, so the page might end up looking a little different because it's going to be keyed to the ActivityBot and the 2 red lights that you have in your kit. So expect a change on the build LED circuits and then the build push button circuits. And another way you can do it is just, if it turns out to be a little too intimidating, we can put that off because we'll be doing some guided circuit building. And so you could instead, if you just wanted to get familiar with the programming, you could instead go through make decisions and then blocks that repeat. So my thought, though, was that we could do some learning to program with just Blockly and then go through, and you'll essentially learn a couple more blocks as you do your light and your push button circuits. So none of these are showstoppers, but I do highly recommend going through and doing these between now and Wednesday. And then last but not least, I have a downloadable app that essentially uses all of the different concepts that are in the coding part. So if you're wanting to just really challenge yourself with Blockly and do a more this is an adjustable app. It's basically the bones of a countdown timer, like an egg timer. You can enter the number of seconds that it'll count, and then it will count for you. And it also warns you if you're choosing something that's going to count for a long time. And so that's an app that you can click and then download, just like we've had you download some of the other apps, or you can try entering it, because that will also give some experience on just finding all the blocks in Blockly. And if you get stuck on any of this, make sure to email me. And that is it for the recorded portion of the workshop.
All right, I will end the recording now.
Thanks for coming, everyone, but stick around if you want to talk or get some tech support.